Hello there. So we are back for the second part of learning assembly. Right now I am going to be working in the exercises of the book that they are mostly related to functions. I mean, actually they are related. They are functions actually, because this is what the chapter 4 of this book is about. So let's go into functions, I guess. There it is. So we want to create a square function which receives one argument and returns the square of that argument. Yeah, that should be actually very easy to make. Let's just create a new folder. Square function. We have quite a bit of programs here. Let's replace recursive function for square func. In the make file, we are building for assembly 32 bits. So that's why we have these params here for 32 bits of assembly. And then let's go to the source code. Let's just remove this, remove this, remove this. We can keep this as a reference, though it's going to help to have the reference. But also, it's actually going to help to do things manually, though. There is no need for memorize this or memorize this, or neither this, I guess. Let me check something though. Let me check the public sort function. Move stack pointer back. Oh, that's because we are. Why 8 instead of. Why 4 instead of 8? Because here it's 8 and then we see power function. Oh, I am so silly. Here actually should be 4, not 8. I'm sorry, I'm just looking at old code. Why it should be 4 here and not 8? Because in this public sort function, I am pushing only one argument. That's 4 bits because it's a long. And to restore the stack pointer, I have to add 4 bytes, not 8. I realized that I made a mistake because I used this example as reference, but in this one I have 2 arguments, not 1. So that's why I do 8 and not 4. So let's keep this one as reference, and it's going to help. And it's quite, I like to write everything from scratch when learning. Obviously, if I am doing development and I am working in an actual work, I will not doing this, but for learning purposes, it's very good to write everything from scratch. Purpose. Calculate the square of a number. Actually, I can. Okay, so what I want to do probably is to first to let's calculate the square of 3 for start as 3 as the first argument of the square function. Call square call square function move the stack pointer back. Basically that. Number of arguments. In this case, the arguments I have are 4 byte arguments, so it's just 4. Otherwise, it will not be like that. Okay, so now let's just move ABX, move the function return value to ABX register, exit status code. Step 10. Common system code to 1. It means exit program. Instruction. Why add them together instead of just moving a parameter there? I do not understand this part. Because why I am doing add instead of move? Why is that? Oh, because I know why. This is a different function. A different software. I mean exercise, I'm sorry. So now let's create a function. Purpose calculate this square number. Wait. First argument number to be square. Output square of the number. I do not have any local variable. So this square is going to be really easy, relatively easy actually. Okay, so let's just type square function square old base pointer. So yes, then yes, we move the make stack pointer the base pointer. Make pointer. There's room for our local. I have no local variables, so oh, may I do have local variables. I want to. I do have local variables though. Yeah, may I do what want a local variable and what be the result. What's the power? What's the base number? What's the current result? I'm sorry. Okay, so basically now I am just doing the basic stuff preparations. Let's write the square end function. This is the standard end of function stuff. End square, whatever. I prefer to call it square end though. Value. Yes. I will then try to optimize this function like with less code, but let's just make it work first and then we optimize. If it's necessary to optimize though. It's actually a bad idea to over trying to optimize something because usually you end fighting against in case of assembly no compiler, but in case of C or another high level language you end fighting against the compiler. And I assure you that unless you are an assembly expert, which I am not, and if you are watching this you probably neither are, there is no point in trying to optimize C code like or trying to do over optimizations because the compiler does optimizations usually far better than your average assembly and C developer. And only you have to be a very expert in assembly to be able to get some optimization over your C code. And even though if you could do it, the point is it will be, is it worthwhile? I mean, is it worthwhile to spend so much time trying to optimize something that maybe the benefits will be very small at the cost of a lot of energy? Restore the stack pointer. Okay. To the base pointer. Fine, that's usually the standard end of function procedure. So that's my first argument. Let's put my first argument in like into this one. And let's just store put first argument in store first argument x in local variable result. This long multiply integral multiply long. It's like that, isn't it? Yes. It should be like let's just now move this square. I could actually make a power function like I did before, but let's just make it simple right now. And then just move fx into this one again. Store result. And let's see if this works. If I did something good or something bad. There is a mistake. Oh, I believe I know what I did wrong. Haha, I knew. No, you are like this. There it is. It throws 9. And that's the proper result. If I set this to 2, it will throw 4. Nice. If I set this to 9, it showed 81. If I set this to 11, it should throw 121. Yes, it's working now. 25. Okay, so it's working, but let's try to make this a bit simpler because I believe I am doing a lot of useless stuff here, if that makes sense. So, do I need a local variable for this? I am not sure. I do tend to believe I do, but I'm not okay. Okay, so let's skip the local variable just for the sake of not abusing the use of registers, but nonetheless, let me check something though. I can actually just do this probably. Wait a second, please. Okay, so I am back. So we are trying to optimize this because there is a lot of stuff here that I probably don't need, and for me, this stuff actually. I believe I can do it just like I can do it just like it actually, I guess. Well, this is interesting though. I can actually do it. And I can just then do here like will this work? It does work, but I am not sure I want to do this, but it does work as you can see. I move the register, I move the value of the fifth parameter here. And then I just multiply that first parameter by itself and we move that into... Actually, I could make this far more fast. I could do this faster and just do this probably. Yes, look at that. So, and with this we don't need any space for our local variables. And my function can just be like that, I guess. But will it work if I call it again? Like, let's just... Let's see if it works if I call this again though. Type the first answer before calling the next function. Oh, I see. Second answer is already in EX, so... Oh, I see what it does. I know what it does. Answer. Restore first answer. And then we just do some kind of... Okay, so 3 squared plus 2 squared should be 13. That makes sense because it's 9 plus 4. So 5 squared. It should be 29. It should be 26. It should be 50. Okay. Yeah, it seems to be working fine. So let's just keep it with the original software, the original values. So here we have our square function in assembly, which is quite good. It's ideal though. Now what I want to do though is probably just, how to call it, I want to give with the book. That's what I want to do. Write a program to test your square function. I already tested that square function, so Convert the maximum program given the section called finding a maximum value chapter 3, so that it's a function. I already did that, so we can take a look at that. Oh, I didn't do that actually. That's oh yes I did. Let me check. No, I didn't do it. So this is interesting then. I didn't do this. So the square function already is okay. So what I want to do now, probably, is to copy this max number function into max func, like that. Yes. So I can go now to max func. I can change the max number to max func first environment max func max func makefile. Let's rename max number into max func in my makefile. Okay, so we have this now. So basically, we want to make this a function. Let's ignore the variables and all of that. What I want to have are the data items. I want to send the data items address into the function as a parameter, and I did that already in another function, in another software I did, and it's this book result. Yes. Copy the memory address at the start to EAX, push EAX. Okay, yes, this is exactly what I did. So this is exactly what I want for this. First thing I want to do is copy the memory address at the start of data items to AAX register and push that to the stack of the function. Then I want to call the function, of course. Call max. Let's just call it max, I guess. Maximum. Max. Just max, it should be okay. But max function. I still think. So I am still a bit sick, it seems. Oh yes, this is what I want, for sure. Move the stack pointer back. Move the stack pointer back. So once I move the stack pointer back, set the index register to EDI to 0. No, this is not I want to do that. I do not want to do that at all. So goodbye all of this. I have the other example for that. Let's just move from the results to exit code. x 30 system call 1 program. Okay, then I want to make that function that basically should push the data. So sorry, that gets the maximum value. So let's make the function now. Goodbye, 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 goodbye. This function input memory location memory address location for start array. Doc, I guess. The list of numbers and zeros. Switch. So now let's try to make this function work. Type max function on this pointer stack pointer base pointer. I will need a local value, that's for sure. I will probably need two local values. Yes, I need basically the current index and the current maximum value probably, so yes. space local storage, and two that let's add here local variables. Index of the current value. Current max value. So what I want to do now is a few things though. First, let's move 0 to set 0 as the current index. No, I'm not going to do that actually. No, no, no. I'm going to use some kind of let me check something about this though. Yes, TBX ECI. Oh, okay, so basically I want to the memory address of my number is in the first value in CX. So the first value in CX. So the okay, so I can put max and this should basically just first AVP to PSP. AVP. Let's see if this works though. Just like the function is not already work, it's just going to return the first value in the list, but let's see if it works. It returns 13. Which is not the first value at all. So we have an issue here. Is there any 13 at all? There is no 13 at all here, so we have some interesting issue here. What if I do this instead? Let me see. Oh, what? I am silly, I guess. I am so silly because I know what's happening. Push invalid. Invalid suffix. Why is not working though? Working 2. Why it's not working though? Let me see what I did here. It seems to have no issue here. Maybe there is something with the make file that I am missing here. Oh yes, of course there's an issue with the make file here. I didn't set the 32 here. I didn't set this here either. It's not a 32-bit. Oh, let's try it. It does not cons the type. Okay. Oh, I am silly. Look at this. It throws 3. Is it 3 the first number in the list? Yes, it seems. Let's just do this. Yes, it seems to be working. I mean, in sense that it does return the first element in the list. But now I do want to loop in the list and get the maximum number. So let's create a max loop. And it will be like this. It will be probably like this, yes. I mean, I'm going to keep that, and then it's going to probably be like this, I guess. Let's just first. The first thing we are going to do is to increment move the move this into here, By the way, if you are probably someone who has experience with assembly, my code will look like trash for you probably, because I feel that for some experienced in assembly, looking at my code will be similar to what I tend to feel when I look at the code of someone starting to learn programming in C on a higher level language. When you know the kind of code that you see all if and else in the main function, no functions at all, lot of fixed arrays and stuff that you look at that and say, yeah, this is totally a new learner in this field. Well, for an experience in assembly programming, this will look like that, or probably even more. But we have to start from some place always. So let's keep this going. Basically now what I do want to do is to first move my current index, my local variable for the current index into the AGI register. So I'm sorry. Now the first thing I want to do actually is to test if my current value, that will be like if current value is 0, jump to index. Okay, let's see. Okay, let's see. No, I see what happened. Yes, I totally get it what's going on. Compare, okay. Compare current value with maximum values. Or I'm sorry, I know. I feel quite sick. Now let's just increment. Okay, let's see what happens if I try to compile this. Okay, infinite loop, it's interesting. Do I have a zero at the end of this or not? Yes, I do have a zero, so there should not be infinite loop at all here. What I am doing wrong then? Oh, I know what I am doing wrong actually. I know very well what I am doing wrong. I have to update my index because I don't know to move. Update index. Zero. Okay, so throws a zero for me. I see that it throws a zero. Why it throws a zero then? Oh, because it throws a zero, then there is no error code. Is it because? Oh, I see. I know why it's because my the current max local variable is yes, I know. There it is. Which is it is the greatest number or not? It seems it is. Let me try with something like this to 7, and the greatest number should be 75 now, which is working there. Excellent. So now let's try to make this code less messy because I made it work, but I am using a lot of local variables and a lot of mess, as you can see probably. And maybe this is not necessary. I mean, I like to use local variables, but maybe I can, for this case, I can just use registers. Nah, but it works and it's quite late, honestly, for me. I have to eat and it's already working. So what I want to say is that yes, you can make this using registers and not so many local variables like I am doing here. I am doing a lot of stuff that it's probably redundant in assembly. But one thing that I learned in this field is that first learn how to do things, then later you can focus in if it looks cool or not, if it's easy to maintain or not, etc. etc. Just make something work and then learn how to do something that it's clean, blah 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 blah. All of that. So here we are, we have our max function in assembly for 32 bits assembly architecture. And explain the problems that were raised with all the standard calling conventions. You think it's better assistant to have. No, I'm not going to write the factorial function, not recursively now right now. Find an application on the computer use regularly, try to locate a specific feature and practice breaking that feature on into functions. Come up with your own calling convention. Can you build a calling convention with using a stack? What test case should we use in our sample program to check to see if it is working properly? Dealing with files. So this is where I left this book by now. In the dealing with files, because it's going to be a very 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 hard chapter for me. So good thing is that I did learn how to work with functions in assembly, and that helps me a lot. So I'm learning, I'm happy, I am learning assembly. It seems that it was not possible to me, but it's happening. So I am now just going to kill the stream and leave it like that. 2 hours of assembly today.